Imagine a laboratory floating 250 miles above Earth. It's traveling at 17,500 miles per hour, where astronauts from around the world live, work, can conduct groundbreaking experiments in a place where gravity barely holds sway. This is not science fiction. This is the International Space Station, a marvel of human ingenuity and global collaboration. The ISS, as it's often called, is a shining example of what humanity can achieve when nations unite for a common purpose. It's a place where science pushes boundaries, where people live in an environment unlike any other, and where we learn what it takes to reach even farther into the cosmos. Today, we're going to explore what the International Space Station is, how it came to be, what life is like aboard this orbiting outpost, and why it matters to all of us here on Earth. So, let's embark on this journey into space. Together, the story of the International Space Station begins with a dream to create a permanent human presence in space. The idea of a space station isn't new. Science fiction writers and scientists have imagined such a place for decades, but turning that dream into reality required unprecedented cooperation between nations, vast technological advancements, and a shared vision for exploration. The ISS is a joint project involving 5 major space agencies: NASA from the United States, Roscosmos from Russia, JAXA from Japan, ESA from Europe, and CSA from Canada. Other countries, like Brazil, Italy, and Malaysia, have also contributed through partnerships or experiments. This collaboration makes the ISS unique, not just a scientific platform, but a symbol of what humanity can do when we work together. Let's start with the basics. What exactly is the International Space Station? At its core, the ISS is a large, habitable spacecraft that orbits Earth. It's about the size of a football field, measuring roughly 356 feet long. It's with a mass of nearly 925,000 pounds. To put that in perspective, it's like a giant floating laboratory, bigger than a 6-bedroom house, and it weighs about as much as 320 cars stacked together. The station is made up of interconnected modules. Think of them as rooms or sections where astronauts live, work, and conduct experiments. These modules are built by different countries, each contributing their expertise to create a cohesive structure. The ISS has been continuously occupied since November 2, 2000, when the first crew arrived, marking the beginning of an unbroken human presence in space. The ISS wasn't built overnight. Its construction began in 1998 and took over a decade to complete, with the final major components added in 2011. The process was like assembling a massive Lego set in space, piece by piece, with astronauts and robotic arms working together during spacewalks. The first module, called Zarya, was launched by Russia in November 1998. Zarya, which means dawn in Russian, provided power and propulsion in the early days. Soon after, the US added Unity, a connecting module that linked different parts of the station. Over the years, more modules were added. Laboratories like Destiny from the US, Columbus from Europe, and Kibo from Japan, as well as living quarters, storage areas, and even a gym. Each piece was launched into orbit aboard rockets or space shuttles and carefully assembled in space. Why build something so complex in such a hostile environment? The answer lies in the unique conditions of space. The ISS orbits Earth in a region called low Earth orbit, about 250 miles above the planet's surface. At this altitude, the pull of Earth's gravity is much weaker, creating a state of microgravity essentially, a near-weightless environment. This makes the ISS an ideal place for scientific research that can't be done on Earth. Experiments conducted on the ISS span biology, physics, astronomy, medicine, and materials science. For example, scientists Study how plants grow in microgravity to understand how we might grow food on long space missions. They explore how the human body adapts to weightlessness, which helps us prepare for future trips to the moon or Mars. They even test new materials and technologies that could improve life back on Earth, from stronger metals to better water filtration. Systems. Let's take a moment to picture what it's like to live on the ISS. Astronauts aboard the station experience a life unlike anything most of us can imagine. They float through the modules, moving effortlessly in any direction because there's no up or down in microgravity. The station is equipped with sleeping bags tethered to walls, so astronauts don't float away while they sleep. Meals are a mix of pre-packaged foods like freeze-dried macaroni and cheese, and fresh items like apples delivered by resupply missions. Eating is a challenge. Food can float away if you're not careful, so astronauts use special trays and utensils. Even drinking water is different. Liquids form floating blobs in microgravity, so astronauts sip from pouches with straws. Daily life on the ISS follows a strict schedule. Astronauts wake up around 6 a.m. Kazoni, or Coordinated Universal Time, just like Greenwich Mean Time. Their day is packed with experiments, maintenance tasks, and exercise. Exercise is critical because in microgravity, muscles and bones weaken without regular use. Astronauts spend about 2 hours a day working out on special equipment. It's like a treadmill with harnesses or a resistance machine that mimics weightlifting. They also perform spacewalks, which are like high-stakes repair missions outside the station. Spacewalks require astronauts to wear bulky suits and work in the vacuum of space, fixing equipment or upgrading systems. These tasks are physically and mentally demanding, but they're essential to keeping the ISS running smoothly. The crew aboard the ISS is small, typically 6 to 7 astronauts at a time, though it can host up to 13 during crew changeovers. These astronauts come from different countries, bringing diverse skills and perspectives. They live together for months, forming tight-knit teams in a confined space. Imagine sharing a house with 6 co-workers floating around with no way to step outside for fresh air. It's a testament to their training and teamwork that they make it work. They communicate in a mix of English and Russian, the two primary languages of the ISS, and they celebrate holidays together, like Thanksgiving or New Year's, often sharing cultural traditions. Now, let's dive into the science that makes the ISS so valuable. The microgravity environment allows researchers to study things in ways that are impossible on Earth. For instance, in gravity, flames burn in a teardrop shape. But in microgravity, they form perfect spheres. This has helped scientists learn more about combustion, which could lead to cleaner, more efficient engines. Medical research is another big focus. Astronauts' bodies adapt to microgravity in fascinating ways. Bones lose density, muscles atrophy, and even their vision can change. Studying these effects helps doctors understand how to keep astronauts healthy on long missions and could improve treatments for conditions like osteoporosis back on Earth. One famous experiment is the alpha magnetic spectrometer, or AMSO2, particle physics detector mounted on the ISS. It's been collecting data on cosmic rays since 2011. It's helping scientists understand the origins of the universe. Another project, called the Cold Atom Lab, creates ultra-cold conditions to study quantum physics. These experiments sound complex, but their results could lead to breakthroughs in technology and our understanding of the cosmos. The ISS also serves as a testing ground for technologies needed for future space exploration, like advanced life support systems that recycle air and water. The ISS isn't just about science. It's also a stepping stone to deeper space exploration. NASA and its partners are planning missions to the Moon and Mars. And the ISS is where we're learning how to make those journeys possible. For example, Long-duration missions on the ISS show us how humans cope with isolation and confined spaces, which will be critical for a multi-year trip to Mars. The station's life support systems, which recycle nearly 90% of the water used. Onboard are prototypes for the systems we'll need on other planets. Even the food grown in experiments, like lettuce and radishes, could one day feed astronauts on distant worlds. But the ISS isn't without its challenges. Maintaining a spacecraft in orbit is incredibly complex. The station is constantly bombarded by micrometeoroids, tiny space rocks that can damage its surface. Its systems, from solar panels to computers, need regular upkeep, and repairs often require risky spacewalks. The station also relies on resupply missions to deliver food, equipment, and experiments. These missions, launched by rockets like SpaceX's Falcon 9 or Russia's Soyuz, are critical to keeping the ISS operational. International politics can complicate things. Tensions between partner nations sometimes affect collaboration, though the ISS has largely remained a model of cooperation. Let's talk about the cost and scale of this endeavor. Building and maintaining the ISS has cost over $150 billion, with annual operating costs around $3 to $4 billion. That might sound like a lot, but consider what it's achieved. Thousands of experiments, countless technological advancements, and a platform for international unity. The US, through NASA, covers the lion's share of the costs, with other nations contributing through their modules and resources. Some argue the money could be better spent elsewhere, but the ISS's benefits, like medical breakthroughs, new materials, and inspiration for future scientists, are hard to quantify. The ISS also inspires people around the world. You can see it from Earth with the naked eye. It looks like a bright star moving across the sky at dawn or dusk. Websites and apps like NASA's Spot the Station tell you when and where to look. For students, the ISS is a gateway to STEM science, technology, engineering, and math. Programs like the Student Spaceflight Experiments program let high schoolers design experiments that actually fly to the ISS. Imagine being a teenager and knowing your project is being tested in space. As we look to the future, the ISS's story is far from over. It's funded to operate through at least 2030, with plans to possibly extend its life. However, the station is aging, and some parts are showing wear. Eventually, it will be retired, likely by deorbiting it safely into the Pacific Ocean, a region called Point Nemo, far from human populations. But its legacy will live on. Private companies like Axiom Space are already planning commercial space stations to take its place. The lessons learned from the ISS will shape these new outposts and our journey to the Moon, Mars, and beyond. Let's reflect on why the ISS matters. It's more than a spacecraft. It's a testament to human curiosity and collaboration. It shows us that even in a divided world, we can come together to achieve something extraordinary. The science conducted there improves life on Earth and prepares us for the next great leap into space. For young people, it's a reminder that the stars are within reach, not just for astronauts, but for anyone who dreams big and works hard. The ISS is a beacon in the sky, a place where humanity's potential shines brightly. So, the next time you look up at night and see a bright point of light streaking across the sky, think about the International Space Station. Think about the astronauts floating inside, conducting experiments that could change our world. Think about the engineers, scientists, and dreamers from around the globe who made it possible. And think about what it means for our future where we don't just look at the stars, but live among them. The International Space Station is more than a machine. It's a symbol of hope, unity, and the endless possibilities that await us in the vastness of space. Pause. Thank you for joining me on this journey. Let's keep looking up.